Hello everyone. In this video, we will learn about the notion of expected value or mean of a random variable. Let me start with the definition. We are assuming that x is a discrete random variable with values x1, x2 up to xn. Then we define the number, the expected value or mean of x. These are same things, different names, okay? Expected value of x or mean of x are the same thing, which we have two ways to denote it, denoted by e of x or just mu is given by. So this expected value or mean, this is a number. So I have to tell you how to compute that number. So e of x is you multiply the first value to the probability of x being equal to first value. Multiply x2 to the probability of x being equal to x2. And go up to xn times probability of x being equal to xn. Well, if f is PDF of x, then you see that, e of x or mu is just x1 times f at x1 plus x2 times f at x2, xn f at xn. So these are the formulas that you have to know and you have to use. So either that or that. Before I start, there's just one small example or remark here that basically that averaging that we use every day, add everything divided by n, that's expected value of a discrete random variable itself. If x is discrete random variable with values, again, x1 up to xn, and the probability, the PDF all of x at any of these points is 1 over n, so they are uniformly distributed, then e of x will be, you see, f of x1 times x1 up to f of x n at xn. So the first one is 1 over n x1 plus 1 over n x2. This goes up to 1 over n xn. Find the common denominator, and you see that in that case, you basically have that average. So this expected value or mean is not something new. You have been working with this thing in this special case when weight of all the values or the probability of all the values are equal. Okay, just have a relation between these two in mind, so that maybe makes it a little bit easier for you to work with. Well, let's do some examples now. We have this random variable with the PDF given. Now we are trying to find the expected value of that. Okay, e of x for this random variable. You multiply the first value to its the value of the PDF at that point. So 0 times 1 over 12 plus 1 times 5 over 12 plus 4 times 2 over 12 and 10 times 4 over 12. So all of them have 12 as denominator. So the first one will give me 0, the second one 5, the third one 8, the fourth one 40. And this will add up to 53 over 12. So the expected value or the mean of this random variable is 53 over 12. Let's do other examples. We have this, remember the game that John was drawing a ball from a bag containing 3 things. So this, we have done this example several times. So here now we are trying to find what is the expected value of the number of balls that John draws from the bag. Well, before we studied the random variable, so here x is the random variable that counts the number of balls drawn by John. And remember we had this tree for that, and then we found the possible values. Well, at least he will draw 1, or then the second value will be 2 balls drawn, 3 balls drawn, and 4 balls drawn. We have found the PDF of this guy in the previous chapter, so I'll just write it here. If you cannot figure it out yourself, go back to those videos and watch those ones. This is 2 over 5, 3 over 10, 1 over 5, and 1 over 10. So now, E of x is basically the expected value or the mean of the number of balls drawn by John. Okay, so what do we do here? We multiply the numbers x to their PDF values and then add them. So in other words, I have 1 times 2 over 5, 2 times 3 over 10, 3 times 1 over 5, and 4 times 1 over 10, then add these guys. This will give me 2 over 5, 3 over 5, I'm simplifying there, 3 over 5, and 2 over 5. The common denominator is there's 6, 10. This is 2. So in average, so if John repeats this experiment thousands of times, and then you try to see what is the average of number of balls he drawn in each experiment, this will be the average. He will be drawing in average 2 balls from the ball, or this is the expected value of the number of balls drawn by John. Okay, so this is another new thing. Joe play a game with her friend. They toss a coin first. If a coin comes up head, so we draw the tree. So if coin comes up head, Joe loses negative $2, so that's right there. And if it comes up a tail, she wins $1. So loses means negative, wins means +1. Okay, and then they draw a card from the standard deck of cards. If the number comes up, then Joe, so this is number, Joe loses $1. And if a face drawn, she will win. So this is face. She will win $4. You see that winning, I put positive numbers. Losing means negative number. And they do this thing again there. Well, this is a probability tree. We know that the half will get head and tail. There are 10 numbers for each suit. There are 40 over 52 and 12 over 52. Actually, I can simplify this and write at 10 over 14, and this will be 4 over 14. And the same thing here, 10 over 14, 4 over 14. Okay, now the money that Joey wins is this. So in this scenario, she wins -1, and she loses $1 and $2. So in total, the random value, the random variable value will be -3. She loses $3. For this one, she will win $2 because she wins $4 and loses -2. For this one, she gets nothing. And for this one, she gets $5. So these are the values. How about the probability side? So maybe I shift this one a little bit lower. So those are the values that Joey win. Now, what about the probabilities? So probability, these are x's, probability of x being equal to x. For this one, we have to multiply these two guys. Half times 10 over 14. So this will be 10 over 28. This one is going to be 4 over 28. I won't simplify for the moment. This will be 10 over 28. And this will be 4 over 28. So we have now our random variable with the values and the probabilities. So now the expected value of the amount of money that Joey win is -3 times 10 over 28. 2 times 4 over 28. 0 times 10 over 28. And 5 times 4 over 28. Now, if I do find the common denominator, this is 28, -30 for the first one, for the second one, 8, for the third one, 0, for the fifth one is 20. And this all together is -2 over 28. So in average, she's going to lose -1 over $14. Well, this is one factor for her to decide if she's going to play this game over and over again. If this averages this number, that means that she's going to lose in long run. So it's not a good game for her to play over and over again. Okay, so this is an introduction for the mean of a discrete random variable. We will learn more about it and other notions as well.